Okay, today we're going to be using what we've been learning with finding the common denominator to rewrite equivalent fractions so that we could add and subtract them. So this is lesson 2.5. So we're going to learn to add and subtract fractions with unlike denominators, and the first thing, like I said, we're going to do is put them and rewrite them in equivalent form with the common denominator. So we already know that the LCD, least common denominator, is equivalent to the least common multiple. So our first problem, the Pacific Ocean covers a third of the Earth's surface. The Atlantic Ocean covers a fifth of the Earth's surface. To find the fraction of the Earth's surface that is covered by both, we could add them together, but they're unlike fractions. To add or subtract unlike fractions, you first have to rewrite them as equivalent fractions with a common denominator. So remember that an equivalent fraction are fractions that represent the same value. So in this, so before we move on, we're going to finish the first problem that we started this PowerPoint with. So if we're talking about the Pacific Ocean, and we said that it covers a third of the Earth's surface, and the Atlantic covers a fifth, we're going to finish this problem to find out the total fraction that both of them cover. So we have a third plus a fifth. So the first thing we want to do is find the LCM of 3 and 5. And you can tell that their greatest common factor is 1, so we know we're going to multiply them together to get 15. And then we're going to rewrite the fractions both with a denominator of 15. So we had a little bit of practice with this when we were comparing our fractions. So 3 times what is 15? Well, we know that it's 5, so we're multiplying 1 by 5. This is important, that you do numerator and denominator by the same factor. This one is multiplied by 3 over 3. Remember, we talked about that fancy form of 1 so that we have an equivalent fraction. So in this case, we would have 8 over 15. Since we use the LCM, there's very rarely any need to reduce, but sometimes you can. But in this case, we look at 8 and 15 and we see if there's any common factors between them, and there's not. So we would know that the fraction of the Earth's surface covered by both oceans is 8/15. So here's an additional example. In a cooking application, we have that Mark made a pizza with pepperoni covering a fourth of the pizza and onions covering another third. What fraction of the pizza is covered by the pepperoni and the onion? So you have a fourth of it and a third of it, and we want to know what fraction is covered by both. So we could look at a bar model like this. And so we're basically in this one combining the two fractions. We want to add a fourth and a third, but you can see that they're not equal sizes. Okay, so we cannot just combine them. So we have to first get them into a common denominator. And you look at the 4 and the 3, and you can find that the least common denominator is 12. Okay, and so we want to rewrite the fractions with a denominator of 12. Okay, so how did we get this one to be 12? We took 4 times 3, so we took 1 times 3. 3 times 4, and 1 times 4. So that's how we rewrote our equivalent fractions. Now we can add them. 3 plus 4 is 7 over 12. And if you look at the diagram, you can see that the common denominator is 12, and so there are 7 portions that are equivalent that equal the 7/12. Okay, we're going to try another one. Tori made a pizza with peppers covering a third of the pizza and ham covering another half. What fraction of the pizza is covered by ham and peppers? So we have our two fractions, a third plus a half. We have a bar model. We're going to get a common denominator between the 3 and the 2. And if you figured out the LCM, it would be 6. So now we rewrite equivalent fractions with a denominator of 6. So 3 times 2, so we take 1 times 2. For the blue fraction, a half, 2 times 3, so we take 1 times 3 to keep the common denominator, and then we add the numerators. And this is what it looks like. The peppers and ham cover 5/6 of the pizza. Okay, you can use any common denominator, but I highly recommend you use the least common denominator to add and subtract fractions. The least common denominator is the least common multiple of the denominator. So we've practiced finding those for a reason. It's going to keep those denominators smaller, which will hopefully keep then the numerators smaller as well. So let's take and try this and apply it to subtraction. So if we're going to write each answer in simplest form, if we have 11/12 minus the 3/8, the first thing we're going to do is, well, we need to find the, let's do this, let's find the LCM of 12 and 8. This is my favorite way of finding the LCM. All right, what's a common factor? We could use 4. Divide them. And we get down here and we have nothing left that we can multiply out. So we multiply in the shape of an L. And we get 4 times 3, which is 12 times 2, which is 24. So the common denominator is going to be 24. All right, so here we're going to do the lowest common denominator. Since the lowest common denominator between 12 and 8 is 24, we're going to rewrite the fractions with a common denominator. We know that for the first fraction, 11/12, 12 times 2, so we can take 11 times 2. And then for the second fraction, 8 times 3, so we can take 3 times 3. So write with a common denominator, and you get 22/24 minus 9/24. So now we can subtract the numerators, 22 minus 9, all over the common denominator, 24. And we can get 13/24. And using the lowest common denominator has allowed us to keep the fraction in lowest term so we don't have to simplify at the end. Okay, let's try this again. In this case, we're going to use the lowest common denominator. And the lowest common denominator of 7/3 is 21. So we want to rewrite the fractions with a denominator of 21. I'll kind of walk you through that just in case. So 7 times 3 gives us a denominator of 21. So we want to take 4 times 3, which is 12. Over here, since we want the denominator to be 21, we're taking 3 times 7, and we use the same factor in the numerator. So when we do our work, I really like it when you show me what it is you're adding or subtracting over the common denominator so that we can get our final answer. 12 minus 7 is 5/21. And then it's also in lowest form. Okay, and finally, we want to try some with mixed numbers. So, if I want to take something like, let's try this, 5 3/5, and let's subtract 4. When we're working with mixed numbers, we want to do the same thing as far as getting a common denominator. And it's usually best if you either keep things as improper fractions or you keep things as mixed numbers. So the first thing we want to do is rewrite this number 4 with a fraction. So remember a mixed number, like if I'm dissecting or looking at the first one. The first one, 5 3/5, is like 5 plus 3/5. So it's a little bit more than the whole number, okay? So since I don't have a fraction part over here with the 4, in order to make a fraction part, I would have to take something away from the 4 to add in to that fraction part, right? So that it would be equivalent to 4. So what's the number that's equal to 4? Like 3 plus 1, right? 3 plus 1 equals 4. So I can write a fancy form of 1 as a fraction to make it a common denominator with this one. So I can write 4 as equal to 3 and 5/5. 3 plus 1 is 4. So I haven't changed the value of it. Now I'm taking my 5 and 3/5 minus my 3 and 5/5. So I'll show you a couple different ways. One, this is not a good example. This is borrowing right out of the gate. Okay, I promise not to give you one on homework like this, but we're going to get a preview of what's to come tomorrow. Since we cannot take 5 from 3, even though we have integers and we know we can do negatives, when you're working with mixed numbers, you would actually have to borrow from the 5. What are we borrowing from the 5? Oh, of course I had the eraser on. We're borrowing a whole number. So if I borrow from the 5, I make it a 4, okay? And what did I borrow? If I borrowed a whole number, I borrowed a fraction equal to 1, so 5/5. So I could rewrite this whole thing as 4 and 8/5. So notice that the second part here, this fraction that is part of it now, is improper, right? It sounds confusing. And the 4 and 8/5 is equivalent to the 5 and 3/5. So now I have it in the right form that I can borrow or subtract, because I can take the 8, so I can take 4 minus 3. I can deal with my larger numbers. 4 minus 3 is going to be 1. I can take my 8 minus my 5 and get 3/5. So 5 and 3/5 minus 4 is equal to 1 and 3/5. Now, here's another thing to think about with all that extra work that I just did. Since there's no fractional part of the 4, what if we just took the 5 minus the 4? What do we get? 1. 3/5, like that's minus 0, would just be that part of it. So we can get the same thing without having to go through all this work and borrowing. So sorry to make it more complicated for you when it could have been just right up front and easy. Okay, that's going to be the end of this presentation. We're going to bring in the mixed numbers tomorrow. So that last example that we did with the mixed numbers won't be on tonight's homework. We'll save that for tomorrow.